Hello everyone, this is Vivek. My registration number is 19BC1043 and I will be talking about consensus in blockchain. So what is consensus? As the cryptocurrency market is growing and we know that it is using blockchain technology. So the consensus is a term that is frequently used is in use. So it is just a way to make all the nodes in the distributed system of the blockchain to come on a common agreement. So as we know that there are hundreds or thousands of transactions are occurring daily, and each transaction needs to be validated before added in the blockchain. So how the different nodes present in the blockchain in this distributed networks will come on a common agreement and will say that one block needs to be added in the chain or not. So this is the way so here only we use consensus algorithm. So it is a procedure through which all the peers of the blockchain network reaches a common agreement about the present state of the distributed ledger. Now, in this way, a consensus algorithm achieves reliability in the blockchain network and establishes trust between unknown peers in a distributed computing environment. Now, in a blockchain consensus protocol, it has some specific objectives such as coming to a common agreement, collaboration, cooperation, and equal rights to every node. So each node should have an equal right to actually propose a block or to validate a block. Now there are various consensus algorithms. So here we will be talking about most common. The first one is the proof of work, second proof of stake, and third proof of burn, and the last proof of capacity. So talking about proof of work. So the proof of work algorithm is actually used by the Bitcoin. So it was first published in 1993 and applied by the Satoshi Nakamoto in the Bitcoin. Now how the proof of work is actually works. So now in a proof of work consensus algorithm, we give different nodes a computational challenge. It is a puzzle which every node needs to solve, and the node who able to solve it first will get the chance to add a new block or to validate a new block in the network. So the puzzle that is actually given to them is if we talk about that, so it in an abstracted form, then we give a data, there is a given data a, then the all the nodes needs to find the number x such that the hash of x appended to that a should result in some target value b. Now the miners bundle up a ground of transactions into a block and try to mine. Now to mine it, we have seen that they need to solve a mathematical problem. Now the miner continue testing different unique values, which we called nonces. Nonces. So until they found a suitable one, and as soon as a miner is able to solve that, the Bitcoin reward and the block gets added in the blockchain by broadcasting that the block has been mined, and other miners who was previously trying to solve the same problem will stop, and the new proposal will then come. Now there are different several features of this system. So first, it is hard to find a solution for the mathematical problem, and the second, it is easy to verify that the solution provided by one of the miner is correct or not. But there are certain issues with the proof of work consensus, especially the first, the 51% risk. It is that like if there is a particular a single entity starts controlling 51% or more than of it nodes, then they can actually corrupt the blockchain by gaining the majority of the network. The second is time consuming. Like we know that they have to solve a mathematical puzzle. So mathematical puzzle solving is actually takes a lot of a time to solve. And another thing is resource consumption. So actually these hard mathematical puzzles needs to be solved only by some strong hardwares and strong resources used, especially electricity that consumed during this process is very high. So it results in some kind of a major resource consumption, which can be bad for the environment also. And another thing is delayed transaction confirmation. So whether the transaction is confirmed or not, it will take nearly 10 to 60 minutes to verify. So so we will move to our another algorithm, which is proof of stake. Now in proof of stake, it is an another kind of algorithm which actually solves the problem of the POW, which was resource consumption for high. So here what we do is, instead of solving a problem, one actually have to purchase or have to a larger stake to become a validator. As we know that a stake is a value or money we bet on certain outcome. Here on the name of stake we have that cryptocurrency. So we can clearly see, to become a candidate to validate the new block and earn the fee from it, then the algorithm chooses from, an algorithm chooses from the pool of candidates the node which will validate the new block. Now this selection algorithm combines the quantity of stake, as we have said, amount of cryptocurrency, and there are other several factors also, like coin age based selection, to and also the randomization process to make the selection fair to everyone on the internet, on the network. So talking about these two, coinage based selection, like this algorithm tracks the time every validator candidate node stays a validator. So the older the node becomes, the higher the chances of it becoming the new validator. And the another is random block selection. So the validator is chosen with a combination of lowest hash value and highest stake. So the node having the best weighted combination of these become the new validator. So talking about how the actual workflow is goes, so nodes makes a transaction. The POS algorithm put all the transaction in a pool first. Now all the nodes contending to become the validator for the next block raise a stake. Now this stake is combined with other factors as we have discussed, coinage or randomized block selection. Now, the validator verifies all the transaction and publish the block. Now, his stake still remain the logged, and forcing reward is also not granted. So this is so that the nodes on the networks can okay the new block first. Now, if the block is okayed, then the validator gets the stake back and the reward too. Now, if the algorithm is using a coin is based mechanism to select validator, then the validator for the current block has its own age reset to 0, because this puts him in a low priority for the next validator's election. So this is done because it is necessary to stop a validator to validate the block again and again to give others a equal opportunity. And also, if the block is not verified by other nodes on the network, the validator loses its stake and marked as bad by the algorithm. So this is the process which follows again and again to force a new block and then new block. So talking about certain features of a proof of stake algorithm. So first of all, the fixed coin existence. As we have seen in POW, whenever the miner able to solve the puzzle, he get a reward he get a reward. So in while getting a reward other than the transaction fees, a new coin gets generated. But here there is nothing like that. Here only the finite number of coins will be there. And second, the transaction fees are the only way to reward to miners here. And third is impractically of the 51 attacker. How? As we know that to be a validator you need to have a stake of cryptocurrency, and to become of to have the 51 to do the 51% attack, you need to own nearly 51% of the stake. So it will be cost them much. So it is impractical for them to attack with the 51% attack. Now talking about the advantages of this POS, first thing is energy efficient. As we have seen, there is no computational power required for that, as it was in POW. The second is decentralization, like in blockchain like Bitcoin. An extra incentive of exponential rewards are in place to join a mining pool, leading to be a more centralized nature in a blockchain. So now rewards are here proportional to the amount of stake. So it provides absolutely no extra age to join a mining pool. Thus, it promotes decentralization up to more extent. And the third is security. As we have seen that a person attempting to attack to a network will have to own 51% of the stake, which is a pretty extensive. So it actually secures the network. And there are still some weaknesses in proof of stake mechanism. The first one is the large stake validators. Like, as we have seen that not a single entity would not be able to purchase a 51% of the stake, because it would be very costly. But what if many different entity with different validated candidates comes together to form to have a majority of stake with them? Then they can increase the chances to increase selection, so like which lead to more and more forging rewards earning. And another thing, it is a very new technology, so POS is like still relatively new. Research is ongoing to find flaws, fix them. So these all are the disadvantages. Now talking about the third algorithm, which is proof of burn. So unlike the previous two algorithm, it is pretty much different. Here we actually burn coins. From the term burn, we actually mean to sending the coin to some to like unreachable addresses. Like validator earns a privilege to mine on the system based on a random selection process first. Like burning coins here, we have seen that they have to send it on unreachable address. So what actually happen when a validator burns a coin? They then the validator actually show a long-term commitment in exchange for their short-term loss. Depending on how POB is implemented, miners may burn the native currency of the blockchain application or the currency of any alternative chain such as Bitcoin or Ethereum. uh, the more coins validator burn, the better are their chances of being selected to mine the next block. So one have to show a commitment, a long-term commitment first to become a validator. So talking about actually how POB works. So here we are talking about the virtual currency. So one needs to actually burn a virtual currency by sending it to unreachable address from where it cannot be retrieved. And then the coin availability is also decreases here as we actually burn the coins, so we are sending the coins to someone from where we can't able to get it back. So unlike POW where the coins were actually getting added in the network, here the coin will just get decreased. Like, to avoid any undue advantage here for any early adopters who come to know about the system very much early. Now the POB actually devised a method that allow for the periodic burning of crypto coins in order to maintain mining. Now anytime a fresh block is mined, the energy of burnt coin decrease slightly. So this is only to actually restrict someone to continuously validate the new coin and also keep some other nodes to have this opportunity. What are the advantages of the POB first? It requires a very little power compared to POW, as here we do not have to solve any kind of a mathematical puzzle. And also it reduces energy consumption by wasting insignificant resources when coins are burned. And also it increases long-term involvement in a project, as a consumer is displaying a big commitment to the currency by foregoing a narrow profit in exchange for a long-term profit. Now the coin distribution is fairer compared to all other consensus. Talking about the disadvantage of POB, it is risky because one doesn't know that will they gain the wealth they have burnt in the future or not. As coins are burnt, so technically, if we see the resources are actually getting wasted because the coin that they are burning actually took some resources previously to get in the network, but now they have got burned. Now also it may suffer from a rich getting richer phenomenon, in which those who are wealthy are getting wealthier by having more coins. Now the last is proof of capacity. Proof of capacity is just an improvement of the first algorithm that we have discussed, which is proof of work. Now, even before mining is started, there is no need to dedicate the processing power and hard disk storage. Because of this, the system is faster than the POW. So basically, instead of computational power, here the space is what much more important. It actually attempts to solve proof of work system hashing problem only, but there is a higher chance of winning the mining conflict if there are more solutions or plots available on the computer. So how actually the proof of capacity work? So the two main steps in this is plotting and the actual mining. So now what is plotting? So plotting is the thing that actually takes time. It may take days or even a week to create plot files. So we need to create a plot files here. Uh, like we will be doing the crypto using the crypto hash functions that for specifically in Burst coin, it's called Shubble. Now Shubble is actually used here. So as a result, it's excellent crypto for proof of capacity currencies. Now this is due to the fact that the pre-computed hashes are stored. So we won't be computing the hashes during the mining. We actually computed previously and then store in a hard disk. So someone with the larger hard disk will able to store more of this nonsense, and nonces are actually then coupled with each other to form scoops. Like each scoop contains two nonces, like 0 and 1 nonces will come together to form a scoop number 0. Then scoop 1 will be formed with the nonces 2 and nonces 3. And then the real mining comes in the real mining. This is the second phase, which is the actual mining. Here what we do is the, like if a miner starts mining and creates a scoop number 40, then the miner would then go to nonce once scoop number 40 and utilize the data from that scoop to compute a deadline value. So a continuous deadline value needs to be find out here, and then then actually the miner chooses the one with the shortest deadline here, after calculating all the deadlines from the hard disk available, from the nonces available in the hard disk that he previously stored. Now, before a miner is authorized to produce a new block, a deadline denotes the amount of time in second that has passed since the last block has was generated. Now, the miner can fabricate a block and claim the block reward if no one else has done so inside the time frame that he provided. Now, for example, like if a miner A sets a minimum deadline of 40 seconds and no other miner can forge the block within that time, A will be guaranteed the opportunity to forge the new block and be paid. So what are the advantages actually it holds? First, any standard hard drive can be used. So there are no restriction like the hardwares in the POW, like ASIC or the GPUs. So these much strong hardwares were actually needed in the POW in Bitcoin, but here there is nothing such criteria. And the second is mining with hard drive saves 30 times more energy than mining with ASICs. So energy consumption is too low here. And third is because everyone has a hard disk, the proof of capacity is more decentralized. So we may even mine from the hard disk of the Android phone. So it makes pretty much simpler to for anyone to get into the network. And other is miners are not required to upgrade their equipment on a regular basis. Older hard disks are just as capable of storing data as the newer ones. Now, after mining is complete, one may wipe the hard drive and puts it back in its original use. So one can participate in the network, and anytime after mining some, he can come back and can use the same devices for their normal uses. Now talking about the disadvantage that it has. Now proof of capacity mining on the other hand has number of drawbacks. So let us talk about that. Technology has been embraced by a smaller number of developers. So it is still in a very under development process. Second, beyond the mining of the coins, the data plotted on the hard disk is useless. Now this suggests that there is a lot of room that isn't being used first. And then we know that proof of capacity mining has reduced entry hurdles that anyone having hard drive or a space to store data can enter. So consumer might also purchase bigger hard drives. Nothing prevents a person from obtaining considerably large hard files and utilizing them to mine the majority of the money. So it can cause some centralization too. And also, like if a mining is getting popular, then there is a chance that hackers will try to take advantage of it. Mining malware is currently infecting many computers all over the world. So like in the POW mining, we have seen that occasionally occasionally be detected as a cause of PC slowdown. But in the POC, on the other hand, makes it considerably more difficult to determine whether your access hardware space is being utilized for illegal reason or not. So thank you. This was my work on consensus in blockchain.